To practice TDD, I just wanted to do a Google search first. Let's search for it. TDD, practice TDD. Let's see what we are presented with. Yeah, there is I see some articles. Yeah, there's a TDD manifesto. It says exercises, and there's a Medium article. There's a GitHub repository. Okay, so while learning TDD, I wanted to make some practice. Like if you can't practice it, if you don't practice it, I think you can't learn it. Like especially TDD, it's something that is learned by practicing for sure. Is when you first read about it, sounds interesting, but you need to see it in action. So you have to find some resources to practice. So yeah, when I do a Google search, I have these results, and this TDD manifesto caught my attention. So let's visit and see what it says. It says TDD manifesto, and the name actually really appealing. It's a manifesto, like they claim that they are the resource to learn TDD. Not sure who built this website, but it looks good, I think. Values, what is not TDD, getting started, need some help, about us. So there are exercises, and exercises here, which I'm going to visit. But here there's a getting started, and it explains why testing first is important, and essence of TDD, when you can't use it. I think this is a good part. Steps to get started. Yeah, and there's the cycle, TDD cycle, which is really important. Okay, so if you read about TDD before, you're already, I think, familiar with these. But I'm here to do some exercise to practice TDD. So the first exercise we have, it's called Kata 1, FizzBuzz. And FizzBuzz is one of the most famous coding exercises for beginners, okay? It's a simple exercise, but it's excellent to start learning the TDD flow with, okay? So I actually solved this before, FizzBuzz with TDD, but I'm gonna solve it again. Maybe this time I'll do it better. Okay, it's actually really simple. Requirements, maybe I can make the page bigger like this. Yeah. FizzBuzz requirements, write a FizzBuzz method that accepts the number as input and returns it as a string. Okay. And we have some notes. Actually, the requirements start here. Start with the minimal failing solution. Keep the 3 rules in mind. This is the TDD flow. Always write just sufficient enough code, okay, to just sufficient enough code to complete the next step, actually. Do not forget to refactor your code after each passing test. Write your assertions relating to exact requirements. Okay, these are notes. Oh yeah, requirements are numbered. For multiples of 3, return fizz instead of the number. For the multiples of 5, return buzz. For numbers that are multiples of both 3 and 5, return FizzBuzz. Okay, so if without TDD, I can just directly define the function, and quite easily I can implement this. But here we are practicing TDD. And I have Visual Studio Code open, and I want to make this a little bigger so that you can see. This is a simple Node app project. I have installed these packages. I'm using Jest, by the way, to run my tests. I'm in TypeScript. TS Jest, TS Node. I have TypeScript, of course. I have the types for Jest, and I have these scripts to run, but I think I'm not going to be using these. Okay, simple TypeScript project with Jest installed. Okay, I have nothing. at the moment, but I'm gonna start right now. Okay, so let's start by creating a file, FizzBuzz test. Do it like this. Yes. Okay, cool. Okay, let's start. So we're using Jest. Let's start with a describe. Do we have a snippet? Nice. Let's just say FizzBuzz test for describe. I'm gonna have a test in it. I want to use a snippet again. Yeah, should return. What was the requirements? It's going to be a FizzBuzz method that accepts a number as input, returns it as a string. Multiples of 3 return fizz. So should return fizz for multiples of 3, but the parameter is a number. Given a number, should return fizz for multiples of 3, buzz for multiples 5, and FizzBuzz for multiples of 15, correct? Yeah, I actually went a bit ahead. There are multiples of both 3 and 5. That's the sentence I should use right now. For multiples of both 3 and 5. Nice. Format our code, but this string is quite long. This looks better. Okay. We have the test. So, okay, so the TDD cycle is write a test, write a failing test, right? Getting started, maybe I can see a nice, yeah, here. So write a failing test first. We need to write a test and it should be failing. And we're going to make the test pass. And we can do whatever we want to make the test pass. And I'm gonna be working at the limits here. Make the test pass, and then you can refactor. The test will pass, and you can refactor. And after refactoring, I'll run the test again, just to see it's still passing, right? So this is the flow. So let's start with writing a failing test, giving a number. Should return fizz. The name of the method is FizzBuzz, correct? I really want to disable Copilot. I want to write this on my own. Okay, disable. Thank you. Restart. Cool. I don't need your help. FizzBuzz, the method. Let's check again. On exercises. Yes, FizzBuzz method, right? The FizzBuzz method. Cool. FizzBuzz method, and it will accept a number. And the number could be, first, we can give any, but I want to start with 9, maybe, right? FizzBuzz 9, given a number, should return FizzBuzz. Let's say const results. Okay, FizzBuzz, and this FizzBuzz, this result, it's trying to remember the syntax of Jest. Expect, we should say. Expect. Result to be, sorry about the music, FizzBuzz. It should return fizz because it's multiple of 3, right? Okay, so this is a failing test, but how do we know it's failing? We have a compile time error, but we should run the test to actually see it's failing. So let's run it. This is Jest Runner extension, by the way. You can use it. It's quite useful. Let's run this test and see it's failing. Running it. So it failed. Cannot find name FizzBuzz. So we have a failing test. And right now, the next step is to make this test pass. Whatever you do, just do those things, make changes, and make the test pass. So how can we make the test pass? First, we need to define this function. Let's define this function. FizzBuzz, call it. And FizzBuzz. FizzBuzz. It's a function called FizzBuzz that accepts a number, okay, and does whatever it does. Okay, right now let's export it so that we can use it on another file. I can import it now. Import. Okay, so we don't have any compile time errors, but the test will still fail. So we need to make the test pass. FizzBuzz 9, and we want result to be fizz. Right now, it's nothing. Why don't we just run it? Let's run it, see it's still failing. Yeah, it's failing. So to make the test pass, the result should be fizz, right? So how can I make this test pass? I can return this. This is going to make the test pass, right? I can do that. Like, I haven't promised you right now that I'm going to have a complete implementation yet. I can return fizz, and this test will pass. Let's run it. It passed. Nice. So we have a test that is passing. Okay, great. So now I can refactor. I can refactor, but I don't see anything I can refactor at the moment. Right? And I think this cycle is complete here. Right? By the way, I'm learning as well. I'm exercising. TDD. Okay, I don't see anything I can refactor here. There's no duplication. So we can start the cycle again by adding a new test, new failing test. Okay, and I'm going to add it here in this it. I think that's valid. No need to create another test case, right? That's what I think. So let's add a new, let's change the test and let's have a failing test again. FizzBuzz supposed to be, this time we can provide 10, I think. Let's have the result. I'll make this left so that I can reassign. Expect result to be, if it's multiples of 5, should be buzz. Okay, since 10 is a multiple of 5, the result should be buzz. Let's run the test, see it's failing. It's failing, so we expected it to be buzz, but we received this, so we have a failing test. Okay, so how can we make this test pass? I need to involve more. I need to involve an implementation here. Like, I need to use the input, right? So inputs. So if input is 9, but first let's work on the new test case. If the input is 10, let's return buzz. And yeah, if input is something else, we still return fizz. Okay, we'll run the test and it should pass. Yeah, it passed. Nice. A new test case is passing. Okay. Like, you may think that what are you doing? So what's the why are you doing this? But I'm I'm going deep into the flow. Like I'm really taking the smallest step and working with the flow with smallest possible steps there are. Yeah, let's continue adding more tests. Let's add more tests. So fizz, if it's down, yeah. 5 is a multiple of 5. So FizzBuzz 5 must be buzz as well, right? Results. Expect the result to be buzz. And this test should fail. This test should fail. And by the way, I can open this here, and I think it should be more readable. Okay. Let's run it and see it's failing. It's failing. So if I provide 5, it returns fizz, but that's not what we want. So here on the test, is this better or not? So maybe this is better. From the window. So if it's 5, it should be buzz, but if it's 10, it should be buzz as well. So I can add another, I can change the Boolean condition, like add or input is 5, return buzz, and this will make the test pass. But yeah, let's do this. If it's 5, return buzz. Let's run the test, see it's passing. Yeah, it passed. Passed the test. And now I can refactor. I made the test pass. So the duplication here is like we are working with constants 10, 5, but the requirements are that requirements are related to the input. If input is multiple of 5 or 3 or both, we return some things. So we can't go on like this. So we need to generalize it. Okay. To generalize this, we need to check if input is multiple of 5. And to do that, we can use the ampersand. If ampersand 5, like if we divide input into 5, should be 0. If it's 0, that means input is a multiple of 5. Okay, and we return buzz for that. Okay, let's run the tests. See, it's still passing. Nice. I have refactored, and the test is still passing. Okay, cool. Let's add a new failing test. Add a new assertion so that the test fails. Let's test 15. FizzBuzz 15. Okay. If we provide 15, we need to get FizzBuzz, correct? Let's do it faster. FizzBuzz, and run the test, and we get the test failed. So we need to make this test pass. You can add an if here and check if the input is 15 and return FizzBuzz, but yeah, we already gone through that. So we can take a bigger step here and add a more implementation. And if the input is both the multiple of 3 and 5, we're going to return FizzBuzz, and what is ampersand 5 return FizzBuzz. Right. Let's run the test. It should pass now. Nice. So I can refactor now and remove the application. And I see an opportunity to refactor. Here, I'm checking if the input is both multiple of 3 and 5, but I'm doing that by using the ampersand of both 3 and 5, but I don't need to check for two numbers, like 3 and 5. If something is a multiple of 3 and 5, it's a multiple of 15, right? So I can just check if it's multiple of 15, right? If it's multiple of 15, return FizzBuzz. Run the test again. Passing. Great. Are we done? We're not done. So we have actually covered the case of multiple of 5 and multiple of both 3 and 5, but we haven't covered the multiple of 3 case. So for that, I need to add a new test. By the way, this function, this FizzBuzz. I want to check the requirements. Returns as string. Okay. 3 to 5 return FizzBuzz. These are the requirements. For multiples of 3, return Fizz. Currently, yeah, I know what I can provide to make this test fail. Let's provide 4. When it's 4, we don't have any requirements, but it shouldn't be Fizz, right? Because we don't have any requirements. If it's none of these things, return that. We don't have that, but if it's multiple of 3, return Fizz. So to return Fizz, it should be multiples of 3. But right now we are returning Fizz for numbers that are not multiples of 3. So shouldn't be. So for FizzBuzz 4, the result not to be, right? Not to be Fizz. So for 4, shouldn't be Fizz. Run the test. It's failing. So because we got Fizz, right? So how can I make this test pass? So for things other than the requirements, we can return something else. Like we can say TDD is not good. TDD is nice, right? We can return anything we want because we don't have a requirement there. Let's run this test. And what did we get? For 9, we wanted to receive Fizz, but we got TDD is nice. So we need to fix this. Like we have a failing test. Let's make the test pass. So for 9, and that means for multiples of 3, we need to return Fizz. But we need to move this if somewhere here. First, we need to check for multiples of 15, correct? Because if we get, for example, 15, since 15 is multiples of 3, it's going to return Fizz, but we don't want that. We want to return FizzBuzz if it's 15. So we need to first check for 15. Okay. Input, nice. Let's run the test and see if we've been able to make it pass. I can refactor now, but I don't see any areas to refactor. Okay, I think we have our implementation. I could have written this in 3-4 minutes without TDD, but here I'm explaining every step. Like this is not going to be, if you are a person that uses TDD in your daily work, you're not doing this, I'm sure, like this, but you are following the flow, the rhythm of TDD in essence, but you're probably most likely not taking those the smallest steps. I just did those, showing you those, just to demonstrate how TDD is working and how small we can make our steps if we want to, but we don't have to go that small, right? And what we have a failing test, we write just enough code to make the test pass, run the test, see it's passing, and then we refactor, right? But we're not allowed to write more code than to make the test pass, because that will be going ahead and that would be adding too much implementation. Because there will be a time to add those too. Because when you add new tests, the tests forces you to add more implementation, like implement it and make it more general, make it more clever. Okay, and that's the FizzBuzz exercise in TDD.